Welcome to this webinar, Fire Up Your Business and Users with RAD Studio 10.1 Berlin's Enterprise Strong Desktop, Mobile, Database, Server, Cloud, and IoT Solutions. It's great to have you with us today. We've got a full team of presenters on today's webinar. Here's the agenda we're going to cover. During the launch of 10.1 Berlin, we went through a lot of the new capabilities in the product. In this webinar, we're going to dive deeper into the enterprise capabilities. Now, we covered a lot of what's new in 10.1 Berlin. This webinar, we're going to focus on the enterprise strong capabilities, as I mentioned, focusing on FireDAC and EMS, REST services, cloud services, database access. So let's get right to it. First up, Jim McKeeth is going to talk about FireDAC in 10.1 Berlin. So Jim, take it away.
So FireDAC is our cross-platform high-performance native database access framework. It works across all platforms and with a huge variety of databases. It has a lot of amazing features, and I'm not going to even get into a quarter or a tenth of these, honestly, today. I'll point out a couple things really cool. There's an in-memory data set with local SQL. This is so cool. You can load stuff into this in-memory data set from any place, whatever it happens to be, flat file, in-memory data, whatever. You can also then do local SQL across that data set and other data sets. So even if you have a data set from another framework, if it's a T data set descendant, you can do a SQL query across these in-memory data sets, doing like a join across data from multiple databases. That is so incredible. I can't tell you how many times I've wished I could do that in the past. Basically, FireDAC has all the features you need built into it. I was just talking to someone the other day, and they said they really needed to add monitoring support because they're having some strange behavior in the database, and he expected to spend like a couple days adding this to the application, and went and looked and like, oh, look, boom, I've turned on monitoring in FireDAC, and it was done in just a few minutes. Lots of great features. You can see here's just a few of them. And just like FireDAC has lots of features across all the platforms, it also supports a lot of databases. Here's a list of databases it supports. Actually, I'm not sure if this is a complete list, but one thing I will point out is that even though this is a fairly extensive list, if there's another database that is not supported here, thanks to DB Express and ODBC, you can access even more databases. So today we're just going to talk about some of the big main databases in use in enterprises today: Oracle, Microsoft SQL Server, and MongoDB. Oracle and Microsoft SQL Server are really the big dogs in the database arena. A lot of the enterprise jobs I've had in the past have used either Oracle or SQL Server. For some people, they're interchangeable in their minds. Other people are very dedicated to one or the other. It's almost a religious thing for them. So that's why we're looking at those two. Very big, very popular in the enterprise field. MongoDB is a newer database. It's part of the NoSQL database, new type of databases going on right now. It's focused on the idea of dealing with data in collections instead of tables. And the idea is that those collections are not always the same. They can vary what fields a row has from record to record. If you talk to the MongoDB people, they're like, oh, you don't need any other database, just use MongoDB. And if you talk to Oracle or SQL Server people, they're going to say, oh, you don't need MongoDB because you can do that with Oracle or SQL Server. So there is some overlap between MongoDB and the regular SQL databases, but really, I think when you get an understanding of the advantages and disadvantages of each, you can find a way that you can include all of these and utilize them for their strengths. And like I said, a lot of stuff we're going to talk about will apply to the other databases as well, but we're just going to focus on these three right now. So working with Oracle, one of the great things about FireDAC is it has the same components across all the databases. So you can use the same table, the same query components, etc. But it also unlocks features specific to each database. This is some of the things specific to Oracle that you can do with FireDAC. And there's a list of some samples that we ship that you can check out that show how to do those specific operations with Oracle as well. Very cool that it kind of gives you the ability to operate at different levels, which is one of the things I love about RAD Studio, Delphi, and C++ builders. You can operate at this high level where you're not so much caring about the platform or the database you're dealing with, but then you can reach down and grab the metal, as it were, and get down there and make those calls and do the things that are specific to the platform or database you're running on. Here's some of the things that are specific to SQL Server. And again, this isn't a complete list. This is just a few things that hopefully will get your interest going. A few of the samples that we ship with that are specific to SQL Server. And then MongoDB. Now, with MongoDB, really, we support all of MongoDB. During Code Rage, I did 2 extensive sessions on MongoDB and still did not completely cover everything you could do with MongoDB. It's a really powerful database. If you're not familiar with it, I would suggest taking a look at it and kind of get more familiar with it so that you can better understand what it can bring for you. Pretty much everything you see in MongoDB is supported through FireDAC's MongoDB support. It's very great, very powerful, lots of great things. For example, geospatial indexes and geospatial queries allows you to do queries and say, hey, how close is this latitude and longitude to another latitude and longitude? And it takes into account curvature of the Earth and everything. Lots of cool stuff. That's not unique to MongoDB. It's available in other databases as well, but still a very, very cool feature. So let's take a look at some of this in action. So I'm going to show you how to connect to Oracle. We're going to start with the Data Explorer. And if you come over here, you can expand either FireDAC or DB Express. We're going to use FireDAC right now. And come down here and find Oracle Server. Now, this is a list of all the databases that FireDAC supports. Also, notice there is ODBC and DB Express, which unlocks even more databases that you can support through those indirection layers. So under Oracle, we're going to, right now we have nothing under it, so we're going to right-click on it and say Add New Connection. And I'm going to call it HR for Human Resources. This is going to open up the FireDAC connection editor and select the driver ID Aura, which is the one you use for Oracle. We need to specify the database. You can do this a number of ways. If you have your TNS name set up, you can just specify the alias there, or use a full definition like you see here that explicitly specifies the service name, host, protocol, etc. So we're going to use that right now in here. There's actually like 3 or 4 other options as well for things you can do. We're going to specify a username and a password. Notice it supports OS authentication. And I'm going to specify the default schema and current schema as HR as well. One thing that's really cool about FireDAC though as well is you can actually come over here to the SQL script tab and you can run a SQL query actually once I connect to it. Let me connect to it, test. There we go, connection established. And I can come over here and I can run a query against the database. So dual is the mystery table that always has 1 column, 1 row with an X in it, and run that here. So you can actually check and say, hey, am I in the right database? Is things working like I expected? So it's more than just a simple test, but actually going in and querying the data all from the screen here. Lots of great options. We're going to go ahead and hit OK. And so now we've created the entry in Data Explorer for Oracle. So let's make a new application. New multi-device application. Works the same on VCL or FireMonkey. I'm just doing FireMonkey for now. And here's a list of all the tables. Now, notice that it includes all the other tables here and other namespaces, or the schemas, but it has these are the HR schemas. Because I mouse over and you can see they're .hr, .tables, .jobs. But it has the HR taken off because I told it that those were assumed that it was that schema. So I can come in here and let's say, I want to see my employees. I can come here and see what rows are in there. Take a look at that. So I could drag just an individual row or I could grab a whole table. Let's do a whole table. And let's connect to the database. Let's get some of that fantastic design time data going here and bind visually. And there we go. So let's hide those non-visual components. And we can run this on Windows and see all of our data. So there we go, just really quick. We've connected to an Oracle database. We've pulled some data in there through the Data Explorer, bound it to a grid, and are now displaying to the user at runtime. This does require that you have the Oracle driver installed on your machine. I found that the full install works better than the instant client thin install, but you may know more about Oracle than I do. It's been a while since I've used it, and you may be able to get it working without using the full install. So I'll show you how to connect to Microsoft SQL Server. We're going to go to the Data Explorer here, and we'll expand FireDAC, come on here to Microsoft SQL Server. Right now I have nothing defined here. You may have one already. If not, just come in here and we'll say Northwind And it brings up the connection editor with MS SQL selected. So I can come here, and the database we're going to connect to is on server. Put the server IP address here. Database is going to be Northwind and SA master key. Don't tell me what my password. All right, I think if I did that right, I hit test. Connection established successfully. At this point, we're able to connect. There's lots of other options here. OS authentication, Mars. You can do control the encryption, default catalogs schemas, current catalog schemas, etc. is all available too. So once we're done with that, we can come over here and expand Northwind. We see the tables, the views, and the stored procedures. There's all our views. Here's all our tables. Let's go ahead and make I will do a VCL application this time. What the heck? Mix it up. And we'll display our employees. So let's go ahead and select our table. Connect it. And I'll bind it visually. Although it works with either type, any type of binding you want to use. If you want to use traditional database binding, you can do that as well. And let's hide those non-visual controls. And we'll run this. There we go. We've connected to SQL Server through Data Explorer, pulled some data down onto a form, created an application, and ran it to display to the user. I have installed the native SQL driver on Windows. On the newer versions of Windows, usually have an older version of the SQL driver already installed, but for best results, I suggest installing the latest SQL driver from Microsoft. In addition to traditional RDBMSs, Data Explorer can also connect to NoSQL databases, MongoDB. Just come in here under FireDAC, MongoDB, add new connection. We'll call it restaurants as our friendly name. And we just define it here. The driver ID is called Mongo. We give it a server IP address. Since I'm not connecting to a local server, it's a remote IP address. If I'm using username and password, I can provide those here. In this case, I'm not. You can use Mongo Advanced to pass advanced parameters to MongoDB during the connection. And you can optionally specify a database as well. I'm going to go ahead and hit test. And we've connected successfully to MongoDB. So now we've created our restaurants connection here. And I can expand this, and it shows the option to show tables, views, and procedures. But there's not really the concept of tables, views, and procedures in MongoDB. It's different. MongoDB has collections instead of tables. When you know more about MongoDB, you'll understand why that's different. So for now, I'm just going to go ahead and leave this like it is, and I'll show you how we'll connect to it. I'm going to say new. We'll do a FireMonkey application. This works with VCL as well. And we're going to drag our connection over here. Once we've done that, we're going to come over here and we're going to find a Mongo query. Notice we have a Mongo dataset, query, and pipeline. These components are specific to MongoDB because, like I said, MongoDB is different. It doesn't have traditional datasets. It doesn't have tables. And so the way you work with them is a little differently. So that's why we have custom components for it. A pipeline is used to transform data. It's very, very cool technology. And let's specify a database name here. So it's already got our connection here. So a database is test. So you notice it has enumerated all the databases available to us, and the collection is restaurants. Again, it's enumerated that, and so it connects to it or finds that automatically. And now we'll connect to it. Once we've done that, we're going to bind this. We'll bind visually, and we'll just link to new control the grid. Okay. And here we go. We've connected to our MongoDB database, got design time data. So now we're going to run this for our user. Again, you have to install the MongoDB client. That's all explained in the doc wiki. And one thing that's really cool here, and I'll expand this so you can see this, is MongoDB has the concept of embedded collections. So a collection can have a collection embedded in it. In this case, we have the address is embedded. And so we have the coordinates, we have the street address, zip code, street name, etc., all embedded in here. The grid's able to handle that automatically. Very cool. And that's all there is to connecting to MongoDB.
Thanks, Jim. And now I'm going to show you how to build Internet of Things based applications using the ThingConnect components and framework. And then I'll also talk about how you can take those devices and connect them into an enterprise mobility service. And Stephen will show you later how that works in action. The ThingConnect IoT framework is a set of components and runtime library that allows you to take off-the-shelf smart devices talking through Bluetooth Low Energy and add those inside of your applications. There's all sorts of pre-built components that are sitting in the Get It Package Manager library for you to download and integrate into your own applications. There are device components for scales, heart rate monitors, home automation, and many more. So you take a look at the Tools Get It Package Manager, and you'll see what's available for 10.1 Berlin. I'd like to show you the new Internet of Things, or IoT support, that we've added with components for specific IoT devices in RAD Studio 10.1 Berlin. We've had Bluetooth LE support in previous releases to talk to IoT devices. And we've had a T Bluetooth LE component that you could also use to connect to Bluetooth low energy devices. In RAD Studio 10.1 Berlin, we have a set of components for Internet of Things development that are custom built for specific devices. We also have generic device capabilities as well for Bluetooth LE. To find these new components, you go to the Tools Get It Package Manager. And in the Package Manager, you'll see all the different libraries, components, tools that are currently available on our Get It server. And we can sort by the different categories. If we just want to see libraries, for example, we want to see components. We can also choose the Internet of Things. Right now, there's 52 Internet of Things device support that's available on the Get It server. A mixture of blood pressure devices, weight scales, lights, speed indicators. You can hover over them and it'll tell you more about each of these device interfaces. There's our beacon fence technology where you can specify an area with beacons and then build location-aware applications inside of the beacon fenced area using proximity-based development with Bluetooth LE beacons. So we can go through and see all the different devices that are available. We can also search for a specific device. What I'm looking for is I'm looking for the Polar H7 heart rate monitor that I'm wearing. I have a chest strap with the Polar H7, and all of these devices are part of our ThingConnect technology, which allows you to easily connect to the different devices. So what we'll do is we'll install this Polar heart rate monitor ThingConnect IoT device, and that'll bring in the component pack specific for the Polar H7 smart heart rate monitor. So we click install. We agree to the license. It downloads the component package and installs it into our IDE. So now it's compiling the component, the runtime library parts, and also a sample program that you can use to learn about programming the Polar H7 heart rate monitor. And then once it's installed, it then changes to uninstall so that if later you don't need the component anymore, you can come back into the Get It Package Manager and uninstall it. And now it's loaded up the sample program that was also available and downloaded as part of the components. We have down here a couple of components. One is the Polar heart rate monitor specifically and the Bluetooth Discovery Manager. So the heart rate monitor component is type T Polar heart rate monitor. It has a device name and then other properties that we can use as part of working with this heart rate monitor. Also down in the component palette, you'll now see a new category called the Internet of Things. And in there, those two components, the Bluetooth Device Discovery Manager, as well as the Polar heart rate monitor. And if you hover over it, it tells you which platforms each of these works with. The T Bluetooth Device Discovery Manager is a general purpose component for discovering different Bluetooth LE devices. And then the T Polar heart rate monitor is specific to the heart rate monitor. We also have in the Get It Package Manager library, we have a generic heart rate monitor that can be used with any GAT standard heart rate monitor. All right, so this sample application is there just to get you started. It's got a button here that says click to discover BLE or Bluetooth LE devices. So if it's already connected, we'll disconnect from it. And then otherwise, we'll go and call the Bluetooth Device Discovery Manager Discover Devices method. And then if it finds the polar heart rate monitor, then we'll add it to the list of devices by getting its device name. And then once we have a list of discovered devices, then we can go and turn on the Discover button enabled. And then further down in the demo source code, we'll go and get all of the services that are associated with that device. And we can also go and look and find any of the characteristics as well. And at that point, we can see data coming from the polar heart rate monitor. So it's a nice pre-built sample for you to explore how to use the heart rate monitor component. So on Device Connect, update and enable a combo box that we can use. On Device Connection Error, disconnect. On Device Discovered, here we'll add to the list of devices we might have found multiple polar heart rate monitors, for example. So here in the polar heart rate monitor demo app, we have the Windows desktop view. We can also go and choose a different platform and then, for example, see what it's going to look like on an OS X desktop. We can also go and create or look at what the view might be on an iPhone 4.7-inch device. You can choose and or create views for additional available devices. You can also create your own custom device views. So I'm going to set my target to be my iOS device. Let's just make sure that I've got my provisioning profile set up for all my projects. For development, I'll use my iOS team provisioning profile and my developer key. We've looked at what the code behind for this sample demo program that is included with the download from the Get It package manager for the polar heart rate monitor component. So we'll compile and run this sample over on my iOS device, my iPhone 6. So here the polar heart rate demo has been loaded and is now going to be launched. We can click the Discover Bluetooth Devices, looking for heart rate monitor. And there's my Polar H7. My device ID is 2F1E45. So we can select that, and then it's connected now. So we'll click in the combo box, and we see 3 different services: the heart rate, the device information, and the battery service. Then we'll click on the property that we want, for example, getting the serial number, and we'll click the read, and it gives us the serial number of the device. We go back, for example, and choose the battery service. The property we want just is the battery level. So let's read the battery level. And it gives us the value of the battery is at 74%. And then finally, we can go and say, get what we really want is the heart rate. And on the heart rate, we can find out what the body sensor location is. So we'll read that. And I'm using the chest strap, so it knows I've got a chest strap versus a ear, finger, and so on. If the device has a notification or indication service, we can subscribe to that service. So for example, here's the heart rate service. Let's go and get the heart rate measurement property, and we can subscribe to the heart rate. And now it'll tell me what the heart rate is. And so if I move a little bit in one way or another, or jump up and down, you'll see that my beats per minute will change over time. Let's go and look at, in my case, an Android 4-inch phone view. We can run the same application on Android, in my case, the Samsung Galaxy S4, and build and run the same demo on Android. Okay, here comes the splash screen, and here comes the app. So let's click to discover our Bluetooth LE devices. So it's calling the Discover Devices method. And then once it's discovered the devices we're looking for, in this case, the Polar H7, we'll click on the device to connect to it. We're now connected, so we can go and look at the different services that are available. Again, heart rate, device information, battery service. Let's choose the heart rate. What is the body sensor location? Let's read that value. Again, it's I'm using the chest strap, so the heart rate body sensor location is on my chest. Go down here to the services, in this particular case, the heart rate. I want to do the heart rate measurement, and it's a notification property, so I can subscribe to it, and it will start displaying the heart rate. And again, if I start moving around, you'll see that my heart rate goes up as I was standing up and sitting down for a moment. And then when we're done with the device, we just click disconnect and we can switch back to our IDE. I've shown you how to use the Get It package manager to download an Internet of Things ThingConnect specific device component for the polar heart rate monitor. That also includes a sample application that you can use to learn how to build your own custom applications using the polar heart rate monitor and the Bluetooth device discovery manager components. See the calls that are associated with, for example, subscribing to the heart rate on the heart rate monitor. We'll call subscribe heart rate measurement on the polar heart rate monitor. While we're subscribing to the heart rate measurement, if we go back to the heart rate monitor, it has an event on heart rate measurement update. So if we see that event handler, it just goes into the little memo box and it goes and gets the value from the update handler for the heart rate measurement. So that's how easy it is to start programming for the Internet of Things using the tools Get It Package Manager in RAD Studio 10.1 Berlin for all these different categories of devices: smart switches, temperature gauges, door locks, speed sensors, dimmers, gas leak sensor, weight scales, and so on. And having the component pre-built for you by downloading it from Get It Package Manager, it gets installed into your IDE. And along with each of those IoT device component support, we give you a sample application so that you can look at the source code to learn how to use the components in your own applications to build custom applications. So have fun using the Internet of Things components in the RAD Studio 10.1 Berlin Get It Package Manager and start developing for the Internet of Things today using Delphi and C++ Builder. We can use these components to get data from these devices and use them inside of desktop and mobile applications. What if you want to have a turnkey application that takes data from these different devices and stores it, for example, or sends it off to other client applications? Maybe you're doing a real-time monitoring type system, for example, to see if a door is open or closed, if a light is on or off. You can use the new ThingPoint Edge services, which is a software stack for building and deploying modules. You can collect the data, you can filter the data, you can cache it in a SQL database, which is Interbase, we call it ThingBase. And you can also communicate through REST APIs to client applications who want to access the data that's coming from these different ThingConnect devices. Once you've created your Edge modules and you've registered them in your RAD server, then you can build ThingPoint applications that can talk to smart devices, get data from them, and then pass that data back through the Edge modules to your RAD server. And then you can have other client applications that can get that data as it comes in. All of this is provided by the RAD server stack for you to be able to build desktop applications, mobile applications on the client side, to create ThingPoint applications that can talk between smart devices and the RAD server. MANNARINO is going to talk about the RAD server development lifecycle, show you some sample applications, and explain how the REST-based architecture can be deployed and then used from different desktop and mobile client applications. Go ahead, Al.
RAD Server is a set of services that provide a turnkey solution for building multi-tier applications. The RAD Server is a REST web service that supplies a ready-made administrative API and which can easily be extended with custom endpoints. RAD Server is a turnkey RAD application server that provides a robust out-of-the-box backend platform on which to build and deploy your Delphi and C++ Builder code and application services. With RAD Server, there is no longer a need to build your own backend servers and services. With RAD Server, you simply load your Delphi and or C++ builder methods into RAD server and publish your backend code to any client via REST JSON endpoints. Built-in services and integrations like enterprise database integration, location and proximity tracking, built-in data store, and Internet of Things edgeware connectivity provide all the most common functionality and access to key external systems. RAD Server is a single, easy to use, and easy to deploy server. And RAD Server is built on Embarcadero's Enterprise Mobility Services EMS core technology. The three key items with the RAD server are REST endpoint publishing for your APIs. RAD server is an application server for your backend for your Delphi or C++ builder code. You put your Delphi or C++ builder code into RAD server and it creates manageable REST endpoints. Now let's look at how to add existing or new Delphi or C++ builder code to RAD server and create REST endpoints.
As we see here, it's this EMS server. It's running on my Windows IP address in the default port of 8080. So now you're able to call these EMS administrative APIs. So EMS being this turnkey middleware server. So out of the box, you get these administrative REST APIs for built-in resources to do version, users, groups, and installations. And as you can see here, these resources expose endpoints like get users. You know, for users, I can either get all users or get an individual user. So EMS is using standard HTTP, REST, and JSON, JavaScript object notation. So we can call these endpoints from a browser. So if I open up a browser, you know, by default it says do the version endpoint. Instead of version, I could ask for users. And here's all the users that I got registered. So you see for users, it did the get, so it returned a JSON array of all of my users. But if you looked at users, it also had a get item. So I can pick an individual user, and I can ask just for its JSON object to be returned. So if I take this user here and say I don't want all users to come back, I just want this individual user with this individual ID, then instead of getting back that JSON array, we just get back the JSON object just for this one user. So one way of accessing the EMS server is through this browser for testing purposes. So by default, we have these administrative APIs in here, but we want to now be able to extend the endpoints and the resources with our own custom resources and endpoints. So when you extend this EMS server using runtime packages that we're going to define and register resources, and we do that by this nice wizard inside of RAD Studio. So if you go to File, New, Other, you'll see for both C Builder and for Delphi, you have a new EMS node, and from this node is where we can create new EMS packages. And inside these EMS packages is where we create our modules, and those modules become our new endpoints and our resources that we can use to extend it. So, for example, if we want to create a new custom resource, a new custom endpoints, we'll say package. So you can create an empty package that doesn't register the resource. You can do that later, but in our case, we want to create a package with the resource that we want to get registered to the EMS server. Resource name, I'll just call it demo for now. You can put it inside of a data module. Now, data module is usually reserved for if you're going to connect to back-end databases. It gives you a nice surface to add, data access components, or it could be in a standalone unit. But I'm going to pick it as a data module because I like working with data modules. And then these are the endpoints that you can ask for or include. Get item, post, put item, and delete item. So you can select them all if you want. So this module gets created. And as you see here, it's a DPL, so it's a package. So this package cannot run on its own. So to help us, either on the run parameters, we see here when we run this project, it's going to first start the EMS developer server, and then it's going to load this package into the server with our newly created custom resources and endpoints. So if we look at what it creates by default, you'll see here it created a resource name of demo that's inside of a T data module, and we have our get and our get item post. If you take a look at some of these have this resource suffix item, and those are the ones that allow me to pass parameters to it. So for example, if I just did a get, I get everything returned. But if I did a get item, I can also pass an individual item like we did for get users to return one individual user. We have the same for put item and the same for delete. So inside of here is where you would add your additional custom resources and endpoints. So these are the same files we created. This time I called my resource name my resource inside of a T data module. What I did for this one is I created a new custom endpoint called reverse string. So its signature is very similar to all of these others. So, and because it's a reverse string where I want to pass it in a value, a parameter, and then run the reverse string on it, it has this resource suffix on here. And then to implement it, similar to how we used to do with the if you ever ran a data snap server and you asked for the sample methods, this is kind of one of those sample reverse string methods we did there. So here's the implementation of reverse string. Get the reverse string, pass in an item, and then do the reverse string function on it. And that reverse string function is part of system string utils. So the great way or the great reason to use RAD Studio to create these custom resources and endpoints is you can use all the power of Delphi and or C++ Builder to create these custom endpoints for you.
A second key item with RAD Server is an integration platform for integration middleware for integrating databases and devices. Now let's look at how to integrate with databases using RAD Server.
So we're going to show another EMS server where we included a FireDAC and a data module to get to backend databases. So kind of just how we did before, we ran the EMS wizard. We created this EMS FireDAC resource package. Inside of the package, we have a module, and on the data module, we added our FireDAC connection. So this FireDAC connection will connect to whatever backend database you want it to connect to. It's got query components that queries backend database. You can check it here just to make sure it works. Query customers, query the orders. That's all working fine. That's the backend EMS server where we have extended inside of this module. We created this resource name called test inside a data module, and it's got endpoints like get going through FireDAC and post going through FireDAC, and we do their implementation here. And we see here we're using the FireDAC schema adapter. It knows how to save to stream and load from stream. So it's a very powerful capability of this FireDAC schema adapter. Once we return the JSON object out from EMS through FireDAC, we can now take that data and convert it to a nice tabular form to display inside of tables. Let me show you this running and we'll see what it looks like. So again, we see here we created a new resource called test that has endpoints of get records and post updates. So to test it, so if we just ran test, it should return everything back from the database. So if I open up a browser and I pass it test, it goes through EMS, uses the FireDAC connector to get to the backend database and returns a nice JSON array of all the data. So that's cool. So now we can use this endpoint inside of client applications. So for EMS, we include an EMS provider. So the important properties here is where is the EMS server running, what's its URL host, and what port is it running on. There's an EMS FireDAC client, and this tells us the resource that we want to hit. So in our case, we want to hit the test resource. And if we looked at the two functions here, get tables and post tables, so when I call get tables, inside of that test resource, there was the get data endpoint that's going to return data from the EMS server through FireDAC, and the other one was post updates that will, any changes we make will get posted back to the database using this FireDAC data access client component. So EMS server is running. So when I run the client and I do get tables, it does the get data and returns back the data. So you get that nice JSON array that comes back, and we can format it nicely into this master detail type of format through that FireDAC schema component. So that does that very well. Then any changes I make here, if I make a change and I post it, it will do its post. So that works out all fine. So that's a quick look on how you can use EMS custom packages and include the FireDAC data access components to get to back-end database resources and return the results back to these call-in clients.
Third key item with RAD Server is to provide robust application services. Now these are built-in services for what you might have either acquired from third parties or built yourself with Delphi or C++ Builder. Services like user directory, authentication, push notifications, location tracking, and other services like these. Now let's look at push notifications with RAD Server.
So for push notifications, like you see here, we can even use VCL client apps to send push notifications to mobile connected apps to EMS servers, or they can be FireMonkey multi-device apps like we saw running before. So before I had this running on my Android tablet, it looks like this. So in XE8, we added push notification support inside of EMS for both Google Cloud Messaging and Apple push notifications. So you can have a mix of devices registered into EMS, and it's very simple to do the registration. I'm going to say the most coolest new feature we put inside of EMS is be able to do push notifications, but it's very critically important for these mobile architectures because it's the only way, it's the conduit to notify mobile applications even when they're not running on the device. So what's cool about that, there's no background thread that's needed. Part of the Google Cloud Messaging and Apple push notifications does all of this push notifications for us. We give you this ready-to-use component called push events, and this is what it needs to do the push notification. So the only two components I have on here to enable me to do push notifications, one is the EMS provider, like we saw before. Give me the IP address and the port of where the EMS server is running, and then we drop a push events on here, and we just connect the provider name of push events to the EMS provider, and then push events has a event called push events received. So the EMS sends out the push notifications, and then when the client receives the push notification, it triggers this push events push received. And here at the very low level, we package up that push notification either coming from Apple push notification or from the Google Cloud Messaging. So it's as simple as that. Even the basic default EMS server includes push notifications right out of the box. We pre-configure this for you. So then you can create applications to send push notifications. So if I now go to the application we created and I click its test connection, just to make sure I can connect to the backend server, EMS server. If I click on register the installation, it registers this device to the EMS application. So now at this point, the fact that EMS knows about this device makes it easy for me to send out push notifications. So just like how we did before, one nice way to do it, in addition to the EMS console, we give you an EMS management console that we can check authentication, log into it, and we saw we could send push notifications. So I'll just do this very quickly again. Hello, where do I want to send it? So these are all my Android devices that have been installed on here. And when I say go send it, it sends it out there. And we see how easy it is to send a push notification to Android. And the same thing works with Apple on iOS devices.
So that was a quick look at the new Embarcadero RAD server. The development cycle typically is build your client user experience using Delphi or C++ Builder. Then create your server API endpoints by loading the server with your Delphi or C++ Builder code to create your endpoints. Then integrate your enterprise databases, cloud services, or use our Internet of Things framework, which allows you to integrate a wide variety of smart devices into the backend. Then easily add users and groups and API access control for who can access the APIs. You can also use the built-in integrated database persistence engine or use your own external database server. And then you can deploy the RAD server. So today, RAD server supports deploying to Windows services on premises, or you can also deploy to the cloud, such as Amazon AWS, Rackspace, or Microsoft's Azure cloud. Later in the roadmap, we'll add Linux as a deployment platform. The RAD server includes a built-in management portal, allowing you to manage your APIs, users, groups, push notifications, and installations. And the installations are the client devices that have connected to your RAD server. This lets you analyze the activity of all the APIs, the REST endpoints, all user activity, and all connections. And all of this is measured and logged, and then you can analyze all of this from the management portal, showing you how the applications are being used, what REST endpoints are being accessed, when, and by what users and what groups.
Hey, thanks for that great demonstration, Al. And now Stephen Ball's going to show you how you can build into your RAD server modules documentation APIs using YAML. Stephen's also going to show you how the ThingConnect heart rate monitor can be integrated into your RAD server to collect data. So Stephen, let's show people what you can do with embedded documentation for the APIs in a RAD server.
Thanks, David. I'm going to be looking through at the new features within the RAD server to create auto-generated documentation for the APIs that you're sharing through your REST server. Now, this is a really cool feature of EMS, or the RAD server, and I'm going to take you through the kind of key elements. So we're working with some industry standard features here, which then allow some very cool quick connectivity into other programming languages as well. One of the key elements here is Swagger. Now, Swagger, or Swagger.io, if you want to go and visit the website there, basically is a tool that you can use to read YAML. YAML is kind of a subset of JSON. It's kind of a description language that goes beyond kind of what JSON offers, but it documents your API. And using YAML, you're able to import the YAML documentation, and it's quite human readable, into Swagger, and then using Swagger UI or the Swagger editor, you can then see what the documentation looks like. Now, that documentation can then be used through Swagger to generate SDKs for client libraries for a whole host of different programming languages, including JavaScript and Android Java and Xcode and iOS and Scala and PHP, Flash, a whole host of different client-side classes can be generated from that YAML documentation through Swagger, which you can then use to connect into your RESTful API very quickly. Now, this is kind of a similar kind of thing to the way that you have the mobile connectors through DataSnap, but way more. So really, really exciting. So if you want to play around with Swagger, just go to swagger.io. You'll find the links there, but the key place to get to is really GitHub, and on the GitHub repository for Swagger-API /Swagger-UI. And then it took me a moment to work out where I needed to go really, but the key thing is if you go to the download zip, and once you've downloaded that, you don't need to do the building or anything else like that. You can just use what's in the redist folder and the redistribution folder to be able to run a local copy of Swagger UI. And you need to run it locally on your machine, so it's then within the domain to be able to connect to your REST server to then be able to get the full two-way interaction with it, which we're going to have a look at. So there's three key attributes that you need to look for, and then two additional ones that help kind of supplement it and make it a lot richer. So the first three is the endpoint request summary, the endpoint request summary kind of gives a high-level picture of what the API does. You can use it to categorize the API, and then the parameters, which you can then use to define the parameters that are going to be available for the API. And this is really important to declare those with specific attributes so that they're then they then become automatically discoverable through Swagger. And then finally, there's details and responses, so you can define what responses you're going to get from the API. What does a 404 mean? What does a 201 mean? You can define exactly what you're going to get sent back. And that response could also include structures, and those structures you can define globally and then just put a reference point to them in, so you don't have to declare them time and time and time again. And that's really where the endpoint objects, YAML definitions or JSON definitions come in. So using the YAML definitions and JSON definitions, you can define up a structure for your objects, and that goes beyond kind of the JSON name value pair. Using YAML, you can actually define up specific types that are going to be returned back, so it becomes a lot richer. And you can say you're going to get this object and it's going to have this value, and that value is going to be a string, or it's going to be an integer, or it's going to be of a specific type which is then declared as well. So it gives a lot richer return on the documentation. Now, if you want to kind of read in a bit more about that afterwards, then I've got a blog post at delphiaball.co.uk/2016/04/22/swagger-YAML-Delphi. And although it's the same for Delphi and C++, that's there on my blog. So let's have a look at the existing EMS server structure. So you have your EMS server, and you then have an EMS client, and that client calls through REST calls to the EMS server. And you can have obviously multiple clients, they're calling to EMS server. Now, one of those calls that can be made is obviously for the documentation now. And to do that, you call /API/ and then either API doc.json or API doc.yaml. And let's go and have a look at that running. So under the sample projects, and they're here for both C++ and Object Pascal, under database, under EMS, you'll find API doc attributes, sample, and if we go ahead and open up the package here, we can see this is just connecting to employee database table and fetching some data back, which it's then pushing out through a get call. The implementation for that in here is now documented by a few additional attributes that have been added on. So if we just scroll down here, we can see all of them. The first one is the endpoint request summary, saying this is under category of sample tag, and then with the title, description, etc. being passed in. There's also the endpoint request parameter. This one here is called skip, and that allows us to define a query. Here we can see if it's a part of the path, if it's a query, if it's a header, a body, or part of the form data. So here this is forming part of the query, which becomes a kind of question mark on the URL. And then kind of the additional properties define if it's a number, if it's an int32, for example. And there's also the response details. So here we're saying this is response 200, which is OK. And this is returning back an object, and that object is defined as definitions employee table. If we go and have a look at the top here, rather than defining the employee table on every single one of the methods, we can go to the endpoint object YAML definitions, and if we just click the constant that's here. So here we can see the constant that's been defined to tell out the structure of what's being passed back. Now, quite honestly, the quickest way to do this is just to run it once and then execute it, see the data that comes back, and then just take the values out of that. That's a quick way that I've done that in the past. But you can then build up here exactly what it is, the different classes and how they're defined and what they reference. So here, this table object actually references the item object. You can actually work with some of this straight out of the example. So what that gives us as we go ahead and run this server, if we open the browser now, we can see that we're running version 2.1. Let's just go /API. We can see we have endpoints for API doc.yaml. And if we just do API doc.yaml, Here we can now see the YAML documentation, which is pretty readable, defining what's in there. Let's just copy that, and I'm going to go ahead and open up my Swagger UI that I've downloaded. And I'm just going to go, for some reason, just needs to disable it and enable it when I open up the page for the first time. I've got a cross-origin resource sharing plugin for Chrome here that allows me to then explore the documentation. So here's my EMS API documentation that's been imported from that YAML document. And here we can see the sample tag and the get. And here we can see an example which is defined from the constant that we had a look at earlier. We can see the skip that's defined. Now if we hit try it out, we can see the response come back and the data. And if we put kind of skip 5 and hit try it out, we can see now that that's appended as a parameter on the end because it's a query parameter, so working really, really well. And it's got the type defined here as well. So that's pretty cool. You know, the whole documentation is explorable here. We can go and explore the groups that are defined as part of EMS server. And we can see all the attributes and everything limited in there as well. So really, really, really careful. Also easy to use documentation through Swagger. So let's just close this, and I'm going to open up another document. And I'm going to come back to this in a moment. I just want to jump back to where we are. This is now obviously the original EMS server. Now obviously with ThingPoints being added in, what becomes really, really cool is as you add a ThingPoint, obviously it's connected to devices. That self-registers with the EMS server. We can add in a few more ThingPoints and see those register up. These ThingPoints, as they get added, the last thing you want to have to do is update this EMS server to declare the documentation for them. What EMS server actually does is it allows you to query the EMS server, and by exposing then the edge points that or the edge modules that are connected in, the ThingPoints, you can then query the documentation for those and find out what this is connected to, what this is connected to, what APIs this one's exposing. And then that can then be fed back into EMS server and back to the client. So without having to change the EMS server, you can put the core functionality in here, and you can even write methods that will then go through the connected specific servers that support specific APIs to fetch and consolidate something and send it back. You know, that's all possible here. Let's go and run the ThingPoint demo. Now I have been in and just made sure that the documentation has been added in, even in its basic form here. So I'm going to go ahead and run my local ThingPoint server. And let's go ahead and run my ThingPoint out to my remote machine. So here, let's just minimize these slides. I'm just going to open up my PA server. I want to confirm my port, my IP address 192.168.144.1, and this is connecting to 192.168.144.138. So yeah, that's still correct. And I'm going to call this my Mac and activate my Edge module, and yeah, let's just go write that in. So what I've got now, if I go ahead and open up my Swagger index, and let's just make sure that this is enabled okay, and let's go to take my YAML documentation. What we have here now is my Edge modules, and if I go and select, I can see here what's going to be sent back. Let's go and try this out, and here I can now find my Edge module. So I've got my Mac, and let's just close the Edge module part up here and actually have a look at the invocation. In fact, let's just go. I can go and find what resources are available. Now I know it's called measurements, so I'm just going to go ahead and use the get here and execute. And I've got no data returned back, so let's go ahead and collect some data into here and try this out now, and we can now see that we've got the specific data come back directly from that edge point, which is pretty cool. So without having to change my EMS server, my ThingPoint's registered I can find out what's going on with it, and I can find out quite happily through it here. If I go ahead and put down Edge modules, and my Edge module here is called My Mac, I can then find out through the Swagger UI. I'm just going to shortcut that process here to call the API, api.yaml, and let's go ahead now and using Swagger here, explore that. So here I can see I've got measurements, and I can also call detailed. So if I go ahead and try that out, I can now see that I'm getting the additional detail back, which is pretty cool. So all of this has been discoverable without having to write any additional code on our EMS server. So that's pretty much it for the documentation side. Very, very powerful, very, very useful, and look forward to hearing about what you do with your YAML and what you're getting it connected up to in the future.
So thanks for that great presentation and demonstration, Stephen. Finally, Pavel's going to use Amazon S3 storage. He's going to show you how to use the Cloud API to do cloud-based development, which will allow you to integrate cloud-based functionality into an enterprise application that you're building. Go ahead, Pavel.
I'm going to use RAD Studio to build a multi-device application that will store data in Amazon Cloud. Before we can start with building the application, we need to configure the Amazon Simple Storage service. Let's jump to a web browser, and in a web browser, first of all, I need to make sure that I have Amazon Web Services account created. I'm not going to go through the steps of creating the account right now. There is something called Amazon Web Services free tier where you can create your account, and for the first year you can try certain services for free. After you have created your Amazon Web Services account, you can log in into the management console, and you have an access point to all different Amazon Web Services. We are going to specifically go into the simple storage service area, and what we are going to do here, we want to create a bucket where we are going to store our Delphi, our data from our RAD Studio application. So buckets is a concept from a simple storage service. This is how Amazon Simple Storage Service organizes its data. A user can have up to 100 buckets, but within a bucket you can create, upload as much data as you like. We are going to give the name to the bucket. It has to be a lowercase with no spaces or any special characters. So RAD Studio Test 1 will be the name of our bucket, and I'm going to select US standard as a region to create this bucket. This is very important to make sure this is a US standard and not other bucket. Okay, click on create, and I have created a new bucket. So before I can start putting data into this bucket, I need to make sure I have proper access rights. For this, I want to jump into another Amazon Web Services service called Identity and Access Management, and I want to create a dedicated user that I'm going to grant rights to access this new bucket. So I'm going to create a new user. I'm going to give it a name RAD Studio Test 1 user, and the option to generate access key is already checked. So when I click on create, I have an opportunity, one-time opportunity to either view the credentials of my user, or I can download a CSV file with those credentials. This is very important to use these credentials. I need to copy these credentials to in my case, notebook. So I want to open the right thing here, like this, and I'm going to put my credentials here. Okay, so that's I'm going to need it during the development of my application. Okay, so I'm going to close this. Now I have created a RAD Studio test user. When I click on this user, I see there are no policies attached to this user, so this user does not have any rights right now. I'm going to open the inline policies option and click here to generate a new policy. So there is a useful policy generator option, so I can select it and I can specify which policy I want to create. So which service, so this is going to be Amazon S3 service, what actions, all actions, and I need to specify the Amazon resource name of my bucket. So I can jump to the documentation, and in the documentation there is information how to specify my sample ARN for my bucket. So I'm going to copy this syntax and put it in my Amazon resource name, but instead of example bucket I'm going to specify my RAD Studio test 1 bucket. I can click on add statement and go to the next step, and the policy is just a plain JSON file. I can use a validate policy option to find out that my policy is valid and click on apply policy. So right now I have created a simple storage service bucket on Amazon Cloud and created user with credentials that I have secured, and this user has just rights to perform different operations of my newly created RAD Studio test 1 bucket. Now it's time to jump to RAD Studio to create an application to put and retrieve data from this bucket. We can create either a C++ or Delphi multi-device application to work with our Amazon Simple Storage Service. This time I'm going to go for a new multi-device application, Delphi. I'm going to go for a blank application template, and I need to save my application in a new folder. I'm going to create a folder called S3 test Delphi. Okay, so I'm going to keep the unit name as the name of the main form, and the project will be S3 Delphi, and that's fine. Okay, so that's my project. So the very first thing I need to do is to put an Amazon connection info on the form. In the cloud category, in the tool palette, there are two components: Azure connection info for working with Microsoft Azure Cloud, and Amazon connection info. I need to double click on Amazon connection info to put it to the form. In a production code, I would probably put this Amazon connection info on a dedicated data module, but for simplicity I'm going to keep it on the main form. Now I can go into my credentials that I have just copied. I'm going to copy the access key ID and paste it into the account name property of my Amazon connection info, and I'm going to do the same operation with the key. So this is my secret key. I'm going to copy the key here and put it into the other property of Amazon connection info. Okay, that's the first step. So this application is going to be very simple. I'm going to put just an edit component on the form, and I'm going to upload the contents of the edit to my new S3 bucket, and also download this content from the bucket and display it in a message box. I'm going to put some arbitrary string into a text property of my edit, for example, hello from RAD Studio and Amazon Cloud. So that's the string I'm going to store inside of the cloud. So I'm going to put two buttons on the form, one button for uploading this string to the cloud. So I'm going to put an upload text and change the name of this button to button upload, and the second I'm going to put another button for doing the opposite operation, so I'm going to do an button download and change the text property to be download. Okay, so if I double click on a button, I can start writing code. So notice that after adding this component, Amazon connection component to the form, these two files, these two units has been added to the users clause. If I jump to the Amazon API, I see there are different types here. So specifically I want to work with Amazon storage service. So this is a class I need to instantiate in my application code to have access to this, to the functionality of Amazon storage service. So there are many different methods and properties, but specifically I need to call a constructor create, and the constructor accepts the connection info that we have already on the form. And then we can call different methods. We can manipulate buckets, but that's something we cannot do because of our limited privileges. But we can get object and upload object, so there is plenty of functionality here. Okay, so let's define an S3 object, the Amazon storage service. Okay, so I'm going to instantiate this class dot create and pass here this Amazon connection info that I have already on the form. And after you have created something, you need to make sure it is properly freed. Okay, so this S3 class has a method called upload object. So this method accepts a bucket name. So in our case, that's going to be RAD Studio test 1. The object name, so any name to identify our object, and the content, which is just a array of bytes. So I'm going to do this upload object, and for the bucket name I'm going to define a constants, two constants in fact, bucket name, and this is our RAD Studio test 1, RAD Studio test 1 RAD Studio test 1. Okay, and our object name will be test object 1. That's fine. Okay, so now we can start putting here a bucket name, and the object name is fine. But now I need to have a way to convert the text from the edit to just an array of bytes. So I'm going for this, I'm going to use a string stream class that has all the functionality that I have. I can create an instance of this class and pass an arbitrary string, and it has a bytes property that I can use to access this as just a plain array of bytes. So edit1.text, and now in a third parameter I can just do string stream bytes, and this is the property with a write signature. Okay, so I want to see if that was actually successful. So if everything went okay, I'm going to show message okay, and if it was not okay, then I'm going to show a different message like upload failed. Okay, so let's test our application. So click on run, and I'm going to click on upload, and I got an information okay, so it was uploaded okay. I can in fact verify in my directly in my AWS service, so simple storage service. If I now jump into my RAD Studio test bucket, I should see my test object has been just created. Okay, so the second thing to do is to actually perform the opposite operation, to download, to programmatically download this file. So I'm going to copy this code to create a Amazon Storage Service reference and a simple and a string stream reference, but this time I'm going just to instantiate this string stream with no parameter, and this time I'm going to call get object. So this is a similar method that takes a bucket name, object name, and it also takes the object stream. So I can pass the string stream, that is a descendant of a T stream, as a third parameter. So I want to do a get object, and everything is okay. I need to remove these bytes from here. So if I have downloaded this, okay, I'm going to display the contents of the stream. So there is something called data string, or display a message that download failed. Okay, so in fact I have not added code to properly free the string stream, so that something needs to be added to both methods. Let's run this application, and if I click on download, I see hello from RAD Studio and Amazon Cloud, string downloaded from Amazon Simple Storage Service.
Thanks for that great presentation, Pavel. You can also use the Cloud API with Azure Storage as part of your enterprise application. So just wanted to come back to this Berlin at a glance again and summarize what you saw today. You saw FireDAC in action. You saw the enterprise mobility services and the capabilities for integrating Internet of Things. You saw how you can use REST-based services, how you can also document those REST-based services, and finally, how you can use cloud-based storage as part of an enterprise solution. And we have a special offer until May 19th for purchases and updates of RAD Studio, C++ Builder, and Delphi 10.1 Berlin. You can also get the discounts for FireDAC client server add-ons and mobile add-ons. And now it's time for your questions. Our email addresses are here on the screen. Feel free to contact us at any time, but put your questions in the Q&A log, and we'll do our best to answer your questions during the webinar. And if we can't, we'll follow up with you via email.
There were a few questions from Update subscription customers, how to proceed and get 10.1. Go to Code Central. You can download the ISO file. If you have active Update subscription, check using the license manager in the bin folder. You can just install 10.1, and since you have active Update subscription, it'll just use your existing key and it'll just install and you can start using it. I also put a link on the blog post, and I think in the chat window, because there were questions about different devices that we support for Internet of Things. And so I put the link in the doc wiki where we list all the current devices, the healthcare devices, the Cadence devices, home automation devices, and so on. I put those links in the chat window, and they're also in the blog post. So if you're wondering what we're currently supporting, the other way is just if you have 10.1 Berlin, go to Tools, get it Package Manager, and then click on the filter for Internet of Things, and you'll see a list of all of the components that you can install. But if you want to see more information, go to the doc wiki. There's a great page with pictures of each device and links to additional information about how to use them, and also the Bluetooth LE framework that comes with it that supports under the covers the Bluetooth LE support. There was a question about, in the Data Explorer, could you only show user tables and hide the system ones? And we haven't been able to figure out, I don't see an option for doing that. You have access to whatever the rights are when you log on to an Oracle server or a MySQL server or a SQL server or Postgres or whatever. So whatever rights you're granted by the database administrator, you'll see those views, those stored procedures, those tables.
Yeah, that was my experience as well. It was just the ones that you would have visibility for. So that's actually an interesting idea. I would definitely suggest putting that in as a feature request, and maybe we could see that added in the future.
Yep. There was a question about if you have the professional edition, what should you see in the Data Explorer and with FireDAC? And I put in the text that's in the feature matrix. You have local database access support in professional. So Interbase, running locally, IB to go, IB Lite, interbase server on local host, again, local MySQL and so on. So if for some reason you're not seeing those nodes in the Data Explorer, then maybe you have Starter Edition or, but otherwise they should show up. Okay. There's a question about support for accelerometers. We support the accelerometers in smartphones, and again on those IoT devices. There's some cadence devices that cyclists use and so on are also supported through the IoT-based components. You can look at the list of all of those. Let's see. Somebody asked about HBO Silicon Valley. I watch it once in a while, but I don't know. It's TV. What can you say? There's questions about DataSnap and RAD Server /EMS. DataSnap, again, is a general purpose framework that you can bolt together. You can create REST servers, IIS DLLs. You can create using the web broker wizard. You can create REST servers with DataSnap using that wizard, and you can create DataSnap applications as well that work with TCP, HTTP, and HTTPS. DataSnap's continuing to be worked on at the same time as we're extending the functionality of RAD Server EMS, as you saw, with additional functionality, because we have a lot of customers who are asking for pre-built stacks of functionality, user and device management, push notification support. They're asking for that turnkey stack of functionality that they can put on premises or maybe in their own private cloud. So we're working on both. And if you have suggestions and or issues, again, use quality.embarcadero.com to post feature requests and issues. Yeah, edn.embarcadero.com. I went there. They're doing some maintenance work right now, but you can go to Code Central. You can go to community.embarcadero.com and www.embarcadero.com to get all the links and resources that you need, for example, for trial downloads or registered user downloads and so on.
Yeah, I wanted to underline the comment you made about DataSnap versus EMS /RAD Server. I mean, there are technologies in the same space, but they have different goals, different purposes, and different history. DataSnap is not going away. We'll continue to keep supporting it. Every release we do some improvements and cleanup, bug fixing. We introduce some slightly better REST model. But overall, the DataSnap is somehow hampered by the fact that it has a lot of history, and of course, by releasing a newer version of DataSnap, we need to maintain a good level of compatibility with the DataSnap projects that are already out there. So that's why the decision was to try to build something from scratch with a different angle and a different focus, as underlines, more ready to use with pre-built services, but also built with REST in mind from the very beginning, while DataSnap has REST support, but that was added to an existing architecture. EMS is more modern in terms of architecture and can allow you to do things that are more difficult to do on the DataSnap side, but both make sense for different reasons, and both are going to stay around.
Yep.
And one more thing is, I mean, some developers looked into EMS over the last year since it has been released. They felt that the technology behind EMS was extremely nice, very powerful, nice to use. They got worried about the pricing. So what we have partially pre-announced, but you'll get all of the details soon, is that within the next few weeks we'll have a different offering called RAD Server that has a significantly different, meaning significantly lower price tag for the EMS solution. So if you've looked into it and you're worried on the price side, I mean, wait for the offer to come out, and then we can take that discussion further.
And so Ed has been posting feature requests and again, we're putting those, we're asking you to put those in quality.embarcadero.com, get people to vote for them. Marco looks at the feature requests and reports in Quality Central as others do. What he's saying is he'd like to see Data Snap Framework closer to things like Node.js, Express.js, and so on. So keep suggesting. That's great. Thanks, Ed. Okay. Let's see. Oh, there was a question about will there ever be an ORM for in Delphi, and I just responded with an article. There's already 2 ORMs for Delphi. TMS has their Aurelius ORM, and there's the Delphi ORM framework that I think, Marco, wasn't it merged with Spring for D, or somehow they were either merged or they cohabitate?
There is some relationship. I'm not 100% sure about about it. There are also many other similar products that's been around for a long time. Some of them are kind of niche, but I think there are some Daniele Teti worked on. There was Instant Object, that was the first one that came out in Delphi 2 or Delphi 3 timeframe. It's still there, still compatible with the latest version, although it hasn't got like a great following. So there are some solutions in that space that are available, although they're not part of the core product.
Yep. Yeah, so I think that question again about what you should see in Professional Edition is you'll see connection to local databases, not remote databases. If you want to connect to remote databases, either purchase the Enterprise and Above edition, or if you have Professional, purchase the FireDAC client server add-on pack, and that will add the remote SQL database support for you. That's available in the shop site. And I think in the special offer for 10.1 Berlin, it includes not only new licenses and upgrade, but if I go to the RAD offer page, it also says that you can get the 10% discount on the add-ons as well. Let me just go in. I always have to check the terms and conditions. So in RAD offer, again, that's till May 19th. So it says here, okay. It's not for starter and not for academic. That's good. Okay. But otherwise you can get the 10% discount moving to 10.1 Berlin and the add-on packs, mobile pack and client server add-on pack. And all of that. Just go to the RAD offer page and there's terms and conditions and so on that will help you. Okay, anything else that I missed in the Q&A? There were some specific things about what about the large integer or int64 in Oracle. I have to find a table or create one. Jim, I don't know if you tried creating a column that was a 64-bit integer in your local Oracle. I
haven't tried that yet. If you send me an email, jim.mckeeth, MCKEETH at Embarcadero.com with bug number or steps to recreate that, and I'll happily do that. I have Oracle 11G set up right here on a separate instance, and I'll test it.
Yep. Okay, let me make sure. I think those were all of the questions. There were some specific ones that we posted answers to. Anything else to add, anyone, on the panelist area? Wait, maybe something popped up here again. No. Okay.
Hey David, it's Stephen here. I've put in a couple of additional links into the chat. One for a white paper and a webinar replay that Carrie Jensen did on EMS just after it came out originally, which is still a really, really good read and good resource. And also the link to DocWiki, to all the documentation around EMS that's there. There's a huge amount in there to get started and to work your way through.
And 10.0 Seattle and 10.1 Berlin can exist side by side. So if you don't worry about installing 10.1, just read the install notes real quick. There's a question about is 10.1 Berlin a major or minor release? Well, it's an interface breaking change release, right, Marco? Which means you need to go to the technology partners and get your updated components or rebuild your packages.
Yes, it's a new release. The fact that it's called 10.1 doesn't mean it's a minor release. It's just because we got into that numbering scheme that for some time we're going to go to release 10 and then use up a point value for the actual release number.
So the Cloud API can work on both Amazon and Azure. So I think Pavel showed that. He dropped down the Amazon Cloud connection component. There's also an Azure connection component. And then you use the Cloud API that works for both of those platforms.
So there was some questions here about encryption with FireDAC. There's a few options. I'm not exactly sure what it is you're trying to accomplish, but for example, if you're connecting to SQL Server, in the connection screen, there's a parameter you can set to turn on transport encryption, and that will encrypt the data that's being transmitted between SQL Server and your client. As far as encrypting like the SQL Server itself, that's something you do through SQL Server administration. And I believe once you've got your authentication, then it handles all that. So as far as encrypting data at rest, that's handled through SQL Server's encryption or Management Studio, and then encrypting the data and transport is handled through the connection interface for FireDAC. I put the link in there for the documentation on it. If you go to documentation on connecting to SQL Server, it will explain that to you. Now my understanding, for other databases, if they are encrypted at the data at rest, then that's handled completely by the database itself. The exception to that would be SQLite, because it's completely embedded, so FireDAC reads those files directly. Interbase, the encryption's handled, well, you could administer it through FireDAC, but yeah, it's handled by Interbase itself.
Yeah, for SQLite in the FireDAC doc wiki, there's a whole section in the SQLite, connecting to SQLite on SQLite encryption. So I'll find that link again.
So there was a question here about MongoDB being used for an embedded application or single user application. Unfortunately, MongoDB is not available as embedded. It's designed to be installed. Because it's open source, there are some people that have tried to make an embedded version of it, even like running on Android. One note, it is GPL licensed, so if you do embed it in your application, that means your application will become GPL licensed. So definitely talk to an attorney about that implementations if that's not something you're completely comfortable with. You can, however, install MongoDB on the machine that's running your client application. So it can be a single user database server. That's completely fine. Doesn't require special licensing or like that. That's just, you can download it and install it separately for your application. Since it's not embedded, the license doesn't carry over. If that's something you're concerned about, you definitely should talk with legal counsel, though. Don't take that as my advice. But that's my understanding of the way license works. As far as defining the SQL connections programmatically, besides doing it through the designer, yeah, you completely can do all that programmatically. If you take a look at the doc wiki on connecting to the various databases, it explains how to do that. Essentially, you just pass that information to the connection, the FT connection component, and it sets it up as you want it to. So you can do all that programmatically as well. FireDAC is so incredibly powerful. There's so much you can do at design time, and then everything can be done at programmatically at runtime as well. There's been a number of times I've been using FireDAC, or I had some data that was in one database and I needed to move to another database. With the ETL components in FireDAC, I was able to do it all in the designer at design time. I didn't have to run my application. It's so cool, so powerful. Highly, highly recommended. Take a look at the FireDAC skill sprints we did, and they was walk through a lot of great features of FireDAC and help you learn how to get the most out of them. Get It packages are free. I think some of them maybe have a runtime license on them, but for the most part, all of them are free. They're all free to install, at least, as far as I know.
Yeah, I put a note, even beacon fence for 150 meter area with 3 beacons is free. If you want to go bigger and have multiple maps and multiple fenced areas, for example, then you can contact our sales offices and reselling partners and get a license for bigger installations. But all of the IoT components, you just go and grab them. They say install. I think even originally beacon fence, the free 150 square meter 3 beacons, you still would click buy. I think that's changed. I'll have to go check. Originally it was buy, but it was a $0 cost, and that just gave you the license, and then you could do the install. But way to know is if it says install, install it.
Right? This other questions about encrypting transport. Another option you can do is you can use RAD server or use DataSnap, and so you would use FireDAC at the middle tier level to connect the database, and then if you install DataSnap or RAD server into IIS, and then you set up IIS to use SSL and TLS, that would also encrypt your transport. So that's another option for encrypting your transport as well if you're using a database that doesn't support encrypted transport. So FireDAC gives you lots of options for encrypting your transport, and you can combine it with interface for local storage. You get interface to go license for local storage, and you can encrypt your data at rest with your client application as well. So we've got you covered in that regard.
Yeah, and DataSnap and EMS both support HTTPS. So
yep, exactly.
Put your certificate in and information in, and then you're good to go there. In DataSnap, I made a comment, and I'll put the link to Pavel's Delphi Labs for DataSnap. It's got, I think, 11 different tutorials. In there, we also have encryption filters, and even if you do heavyweight callbacks where you open a channel between DataSnap client and server, you can intercept the data before sending and after receiving to do your own whatever encryption it might be. There's also DataSnap encryption filters. The samples we ship are PC1 and RSA, which are very lightweight encryption. That just allows us to ship the product without export controls. And Airbase X7 and Airbase to go E7 support AES encryption at the database and the column level. Al, do you remember which level AES it is? I know it's at least 128, might be higher.
Yeah, we go as high as 256.
Okay. There was a specific question about FireDAC connecting to DB to AS400, and for there, Dimitri, who's the chief architect of FireDAC, recommends using the ODBC interface to AS400. I put a link to a news group conversation with Dimitri that was talking about that. That's probably the best place. If you go into the database news group forum, Dimitri hangs out in there looking for FireDAC specific questions and responds, and a lot of those responses then go into the FAQ in the doc wiki for FireDAC as well. So that's a good place to talk to the architect of FireDAC. There's always the question about T-client dataset via TFD mem table. Jim, I know we had skill sprint several about local SQL and FD mem table and all of that with FireDAC. I recommend these days use FD mem table. Some people have older apps that use client dataset. I think if you have an aggregation like average, sum, something like that, filter in client dataset, but you can use SQL commands on FD mem table, right, Jim?
Right. So with FD, actually, the local SQL components can let you use SQL across any T dataset that's in it. So we recommend FD mem table. There are certain situations. I've talked to some people that are like, oh, well, client server or T client data set works better in this situation, that's fine. Both are still there. We recently made some changes that sped up the performance of both data sets considerably. So it's not like we haven't deprecated or got rid of client data set at this point, but we do recommend, generally speaking, that you use FTM table. Yes, you can use the local SQL component to do local queries across any data sets. Actually, if you check out the skill sprint, FireDAC skill sprint I did on local SQL, I have, I think, 5 or 7 different data sets that are getting data from different sources, different databases. Some of them got data from a REST server, some of them got data from Interbase using the Interbase components. I mean, I found everything I could find as far as different components, and then I used local SQL to do a join across all of those different data sets with data from different sources, and it just worked like magic. It was amazing. So very cool, very powerful stuff. You can do that with that. Check out that skill sprint on FireDAC local SQL. Okay.
And yet you have full access. I mean, there's a whole JSON runtime library. There was these questions about how do you create JSON objects and how do you process JSON-based data. Just go into the doc wiki. There's a whole JSON unit that has all sorts of functionality and operations for working with JSON strings.
Okay, so there's a question here about freeing a string. So the way this works is you're creating an object, a stream object, to hold the data, all right? And you create that at the server side, and then you send the data that was in that stream object to the client application. Now you have 2 different objects there, 2 different stream objects. The one stream object that you create on the server holds the data, and then you send the data out of it. Once you send the data out of it, you have to then free that object that you that held the data. And then on the client side, you would create a new object that would then receive the data into it. And once you've finished processing and dealing with that data, you would then free it. I'm trying to think if there's any scenarios when the framework, the runtime, automatically frees those components for you if you're passing them off to another routine. Generally speaking, if you turn on the warnings about memory leaks and then test it, that's a great way to find out what you're doing wrong and what you're doing right. If you free it and set it to nil, you'll get an error message. If I guess you won't get an error message if someone else tries to free it. Just free it and set it to nil, and you're good to go. So just keep in mind, even though you're sending the data between the client and the server, you're not actually sending the object. The object exists in memory and contains the data that you're transporting back and forth. Hopefully that makes sense, and I haven't missed any issues there.
Well, on mobile you have automatic reference counting, right?
Yes, that's true. On mobile you have automatic reference counting.
You have ARC. So on mobile it's clear. For me, if you create it, free it. That's just me. I don't know. Maybe I'm old.
Yeah. Now, and on mobile, you can call dispose of to clean it up, to free the memory right away. You can set it to nil, stuff like that. So there's other options available on mobile. But yeah, if you're receiving it on mobile, then you don't need to free the stream. So with automatic garbage counting and garbage collection both, you need to understand how they work and how it behaves, because it's not a perfect system. For example, if you have a collection that you've put a bunch of objects into, if you still have a reference to that collection, then you still have a reference to all those objects. And so even if you're like, oh, I've got rid of these objects because I'm not using them anymore someplace else, well, you're still pointing to them someplace else, so therefore they're still in memory. So you really need to be aware of that. You need to use a profiler and see how your app's behaving and stuff like that, because it's easy to have a memory leak even if you do have garbage collection or reference counting. So in those types of scenarios, I call it a memory bag, where you're putting stuff into a collection, for example, and forget they're there. I worked on this one system one time when we had this collection of objects, We kept throwing in this, or kept throwing objects in the collection, and then we're like, oh, we'll just flag these as deleted, and we'll flag them as deleted. So they didn't show up in the UI anymore because they're flagged as deleted. But every time we refresh the data from the database, we throw them in this collection again, and we're like, why is our system running out of memory? And we looked, oh, they're all still in this collection. They just never got actually freed because they're still in the collection flagged as deleted. Anyway, so you can get memory leaks all over. It's not technically a leak. If you are storing data at rest locally and you need to encrypt it, use Interbase to go. It's awesome for that. There are other options. I mean, you could encrypt it yourself, but frankly, don't mess with it. Use Interbase to go, and know it's handled for you. The fact Interbase to go has column level encryption, that is such an awesome feature to have in a database. I'm trying to think if there's any others that do that, but very, very cool stuff. I remember working on a project with Oracle, and Oracle did not offer it. They may have added it since then, but Oracle didn't offer it at the time. We needed column level encryption.
Yeah, I think that's most of the questions. There was this one I'm still trying to think about, because it may be that I'm, yeah, or that it's a typo. It looks like there's an HTTP client, HTTP request, then there's a TDS client for DataSnap, but there's no such thing. I mean, we have the, the HTTP, the net HTTP client request. So maybe that's what the developer is talking about.
I recall the HTTP client does have an on-received data event, and I know I use that with a progress bar to give me the progress of the response download. Yeah. I'm not sure if the question replied to the DataSnap have something equivalent to that.
Yeah. Again, there's no notion. I mean, it's on the request side, you have the received data, and you receive data. I think some people have asked why there isn't some kind of send data, but I mean, I guess if you're doing a post operation, yeah, I need some more information on that question. I don't know if it's a typo with the. So Cedamar, if I'm pronouncing your first name wrong, can you provide some additional information of what you're trying to do there? Because there is on receive data on the net HTTP, which is what we're using everywhere now. We're using the native APIs on each platform. In the Cloud API, DataSnap, EMS, all of that. You can still use the India components if you want to do low-level operations on your own. But everything that's higher level now in Seattle and even more in Berlin is using the platform-specific HTTPS operation stuff. So I mean, there's no DS HTTP client, so that's what's throwing me off. Maybe I'm reading it wrong.
There's a question about here if we recommend FireDAC over the ADO connections to connect to a SQL Server. There's pros and cons to both, I guess. FireDAC is really cool. Even if you're using the ADO components, though, you can actually still use like the FireDAC local SQL and stuff like that with that. So keep that in mind. It doesn't have to be completely one or the other. I would definitely just, suggest that you look at it and say, what is I'm using it for? See if FireDAC has those features. If you're only connecting to one server, then you may not need FireDAC. Or one database, you may not need FireDAC. But like I said, you can mix and match them though, and there's lots of other options.
Here's a question about FireDAC and nested data sets. Yeah.
It handles nested data sets differently. Carrie Jensen explained to me once how it was different. FireDAC does support nested data sets, but it does it differently than client data set. We have a RAD in action with Carrie Jensen. I think he goes into it with that, and he has a white paper about it as well. Let me see if I can find a link for that.
Okay. I'll get that question while I was going to type it. Yeah. For all the links that we find and we post in the Q&A, I will add those links to the blog post. The URL, the short URL is on the screen there. There's a resources section at the end where I'm adding different links to additional resources of information. So you don't catch some of the links here in the webinar or in the chat window. I'll make sure that they all get put into the last part of the blog post for this webinar. And again, the short URL is on the screen. And when I get the replay done after we finish the 3, this is the second of 3 webinars today, we always have the replays up on Embarcadero YouTube channel. And I'll put the link in the blog post for that replay on YouTube as well. So
I put a link in. Oh, sorry. Go ahead.
No, I was just giving you time to search. There you go.
I put the link into the RAD in action. I know that there were some changes to FD table. Wait, no. There were some recent changes to FD table, though, I believe. You have to check out that RAD in action, and you can do a simple test as well to see if it handles the scenario you're looking for. But yeah, I know that Kerry talked about this, but I know that he filed some feature requests, and it may have been updated since then as well. So Kerry Jensen will be the guy to talk to, because he is the master of the T-client data set. And I know he likes FireDAC quite a bit, but he did say there's a couple things specifically that T-client data sets feel great for.
What was the component? Was it TFD schema adapter? If you've got a master detail relationship, it'll send the metadata and data over, and we have samples for that. Marco Cantu had a sample, and it brings it over, and then on the other side of a data snapper, multi-tier or application, pulls it apart, and you can pull it apart easily just by pointing to FD mem tables, and the data gets converted from JSON to internal representation, and then you can use data sources to manipulate, and then it combines it all back together when you do apply updates and sends it back over. So check out FD schema adapter. Am I remembering that right, Jim and Al? I think that's the component.
That's correct, the FD schema adapter, and that's the component I use in that RAD server example to show FireDAC, connecting to a back-end data source and bringing back master detail data. So exactly as you said, David, that's one of its uses.
Okay, so I'm older, but I'm still remembering. Okay, always a good test. I'll be 65 in June, so that's not too bad for an old guy. Remember some of this stuff. Okay, I was looking at FD mem table. I guess I'd have to go back into the what's new sections for the most recent releases to see about changes, any changes to FD mem table. I guess that's the right way to do it. Other people can do that too. If you go to the DocWiki, the Berlin DocWiki homepage, there's always a what's new section for each one, and then and we also have the previous versions as well in the left-hand navigation bar on the DocWiki. So check out those as you want to look at changes that happen between versions that might affect you. Well, master detail, if you've got a transaction started on the database on FD connection, and you do master detail and change and make changes, we have lots of master detail examples using FireDAC and others that ship with the product in the samples. So check out, when you install, you'll find the samples under each of the different versions. So 18 let's see, it's in users, public documents, Embarcadero Studio 18.0 for Berlin, samples. And then if you go into either Object Pascal, and then go to database and FireDAC, and then samples, you'll see all sorts of samples for FireDAC specifically. And those are also, there's links in the doc wiki as well. So you can check all of those out. You can start a transaction on the connection and then do master detail. And also as you're stepping through, once you've defined that relationship using the master source and the field or column, then FireDAC will fetch the data that's needed in the master detail relationship. You can set up even the number of rows to fetch at a time. So DataSnap also lets you throttle some of that. I'm not sure about an EMS, Al, how rows get, the row transfers might get minimized. You don't want to bring over 1 billion rows at a time, for example. It's done at FireDAC connection level. So on the replay, you cannot see the chat, right? You can save, you should be able through the GoToWebinar client, save the chat log and save the question log before I shut it down. You can also just go in there and drag select and copy the things over. Well, FireDAC supports its own briefcase model. You can save FireDAC data locally, and then you can load it again when you come back and be connected, and you call apply updates. So it's the same mechanism in that way about calling apply updates and keeping track of the changes and saving temporarily and loading them back using FDMEM tables. So it's you can also set up, do you want FireDAC has a setting for doing cached updates or not. Otherwise it will send updates automatically, but you can save FDMEM tables locally and reopen, call, apply. And then there were a lot of earlier questions about the IoT and Bluetooth device support. Those are the devices we have right now. I put links in the chat window and in the Q&A log. There's the still T-Bluetooth and T-Bluetooth LE components still exist. Those were introduced earlier in earlier versions. There's now the T-Bluetooth device manager that you can use, and then you can still write your regular Bluetooth LE code if you want, or you can use these pre-built components by installing them from the Get It package manager. There was a question about how to create your own component wrappers. We built a tool internally. We built a tool that takes a device independent language, an IDL, that's sort of like a Delphi class declaration. We built that internally to be able to automate building component wrappers for different IoT devices and also generating sample programs using the same information. That hasn't been productized yet. I think someone also mentioned that there's a couple of classes that we don't provide the support. I think it was the IoT family. Currently, this is the first release of the IoT device support for both Bluetooth LE devices and for Z-Wave. And there's a lot of additional work going on into the future. So in this first release, we haven't packaged up the tool, and we're getting everybody started by using generic component wrappers like the generic heart rate monitor, and then specific ones like the polar heart rate monitor. But I suspect that we'll do more over time as that framework for doing IoT ThingConnect and IoT device support and building ThingPoints and integrating it into your applications and into your server applications, that we'll probably do something to document and maybe figure out a way to get the tools into people's hands. but this is just to start now. There were questions about RAD Server scalability. Again, RAD Server is built on top of the EMS technology that we've released before. It's a REST-based server technology, so a connection comes in with an HTTP or HTTPS call, and something happens, and the result goes back, and then it disconnects. You can create a DLL, and you can run it on as an ISAPI DLL. So it scales as IIS scales. Somebody asked about limitations, and whatever the platform, HTTP, HTTPS, how many HTTP requests coming in at the millisecond time. Go check what Microsoft believes they can handle. At the same time, it depends on what your REST endpoint is doing. If it's doing long-running queries, if it's got to do calling some other services, that request might take some time. But that again is your architecture, not the underlying architecture, which is an HTTP call. There was a question, Jim, about, I don't know that we've actually certified on, it's sort of off topic, but it's device related, Android Wear watches. I know you've done Moto 360. We played with a Sony Smartwatch 3, I think Android Wear 3, but I couldn't find anything where we listed a specific Android Wear version that we supported, like on the platforms page or elsewhere.
Yeah, with Android Wear, it was when the Android Wear watches came out, I tested a handful of them and they all worked. And as new ones have come out, I've tested a few more. At this point, I would say most of the watches should work. Look at it, if the watch doesn't have a display or isn't running Android or something like that, then it's not going to work. Yeah, like if you have like an old Samsung that was run Tizen or whatever it is, that's not going to work. But if it's an Android Wear, I'm not aware of any that have not worked. So, yeah, there's not a list of certified ones, but there's always new ones coming out.
Yeah, and Jim did a blog post, maybe even a skill sprint, I forget. You can build your own form factor for the form designers, and I think you had one example. I think it was the Moto 360. I think you also did Google Glass when we had the first generation Google Glass as a device form factor that you could choose. It's an XML and some other information that you provide to integrate additional views into the views menu of the ID form designer, right?
Yes, yeah. I built one for the Moto 360, one for the LG, one of the LG watches, one for the Samsung. It's really easy to do. It changed a little bit between versions, but the doc wiki's got great information and all the code is out there, so you can download that.
Yep. There were questions about RAD server, white paper, and additional information. Stay tuned. In the next 2 weeks, we'll have more information for you, pricing information, all of that. On May 19th, 2 weeks from today, we're going to have webinars every 2 weeks during this quarter, in May and June, on different specific topics. So in 2 weeks, we're going to have a webinar on May 19th. You'll get invitations. You can also check it out when I post the link and information on the community calendar. And what we're going to do in that webinar is we're going to build a retail business application and show you how it all works using RAD server, beacon fence, beacons, IoT devices like lights that can flash as you walk nearby to catch your attention to an item that's on sale at the end of it's called an end cap when you're at the end of a row. They put special things and special offers at the end of a row in a retail store, whether it's a grocery store or a department store or whatever. So we're gonna do a RAD server turnkey application that's going to be deployed both into a regular server just on a computer, and we're also going to deploy it into Amazon Cloud as a cloud instance, and then have desktop and mobile clients that talk to the endpoints. So it'll bring it all together. Here we showed you lots of little sample demos to introduce some of the concepts again across the wide range. In 2 weeks' time, we're going to build a real, business application and show you how it all gets built and how it works. So stay tuned. You'll get emails, and I'll put, thank you for attending, the email that goes out next week from GoToWebinar, I'll put the link to that May 19th webinar. Same time, 6:11 and 5 p.m. Pacific time. So save the date, May 19th. We're going to bring a whole application, business application together, retail store application. Okay, what else was I doing? I think those were some of the things. There was a question about doing GCM, Google Cloud Messaging, and Apple push notifications without doing a back-end service like EMS or Convey or App42 or Parse, which will depart, but they've given you this. They make the source code available. It's going to depart next January. Jeff Lefebvre, I put the links into the Q&A log in the chat window for Jim's blog post and also Jeff's session. Luis Felipe also showed how to build. It's in Spanish, but the source code is easily readable in the blog post. You can translate with Google browser and Google Translate. So Luis Felipe built his own back-end Delphi-based server that could push and integrate with Apple's push notification system at GCM. You can use in Project Indy HTTP components and do things. So there's lots of different resources out there if you don't want to have a turnkey interface to those push notification systems. You can build your own as well. Let's see. There was a question about other HTTP verbs in EMS. Put suggestions into quality.embarcadero.com for what you want to see. You can also send us an email. The email screen there. Send Marco Cantu an email. Their short URL is there for the blog post. So, and the slides and the samples that we have so far, the rest were either built from scratch or are samples that ship with the product. But Pavel and my IoT samples are in the same zip file in Code Central, and that link is in the chat window as well. Yeah, pricing for RAD server is going to be announced in the next 2 weeks. So between now and when we do the webinar May 19th, there'll be more information about RAD server when that product is launched. We're using the name, but we're showing some of the functionality that's it. All the functionality you saw is in 10.1 Berlin as it relates to EMS. We're using the RAD server name, but there's more pieces and parts like beacon support and IoT support, but it's based on all the technology that is already included in 10.1 Berlin. So you can get started today.
So there's a question here from Scott about implementing a client-server database application with a database in the cloud and then connecting to VCL and mobile apps. And needs to be able to handle the data offline. So in that case, there's two scenarios you could do it with. You could use Interbase on the local machine to store it, and the change views on Interbase are great for that, so that you can just grab what data has changed since you last were there. DataSnap also has some great functionality around briefcase model and being able to deal with data offline. So that would be two scenarios you could use to keep your data local and then sync it up once you're connecting, once you have data restored.
Yep. And yeah, you need something because, well, we have for IB Lite Interbase to Go, we have the client libraries as libraries that get linked into your executables for Windows, Mac, iOS, and Android. But for example, for Oracle, even Oracle has their middleware fusion where you make remote calls to a middle tier, and then in the middle tier, I think they use Java-based technologies. Then it does things to the back-end Oracle database from a mobile client. So there needs to be something you have to do. It can be as simple as using Indy components to push bits back and forth, and then the thing that you talk to is the thing that could have the client libraries for Microsoft SQL Server, Oracle running on Windows or wherever that would then connect to the remote database. I think there was, besides our own, I think there was a MySQL local client and some subset clients I think that DevArt also has that you can link in and make a direct connection to the back-end SQL databases. But they aren't as full-featured of what you can do. I mean, if all you can do is fire a SQL update, then why not fire a SQL update string, send it off, or take a JSON database data set, push it over, and have it handled in a middle tier. But what you have to do is have a mobile client that talks directly to the back-end database, not through some middleware. Then you'll have to explore a few options. I think DevArt might be one. And maybe, I don't know if anybody's done Delphi or C++ Builder on mobile using a MySQL local library. I haven't seen anything like that. But DataSnap, EMS, other middle tiers, build a REST service yourself. Craig Chapman did a skill sprint on building a REST server from scratch and then building clients that talk to REST servers. So you could just do REST calls to a simple REST server, and that REST server could then do the database updates. So there's ways to do that. Our webinars are always recorded. The Q&As are also put into it, and if we have to, we make updates and we put the replays on the Embarcadero YouTube channel. Always have, always will. The link, once I get it done on YouTube, will be in the blog post. So again, save that short URL or bookmark the page, which is the blog post. I changed the date so it's up near the front on the blog scroll on the community site under my blog, but embt.co/Berlin Enterprise with a capital B and a capital E. NexusDB, they announced their support for 10.1 Berlin. I saw emails that they sent me that they have all of that, including their local database working with 10.1 Berlin. So just contact the NexusDB folks, and you can use it. Works with 10.1 Berlin. So
NexusDB doesn't have, or FireDAC doesn't have native support for FireDAC, but there are other solutions for that.
Yeah, they have their own. Yep.
They have their own.
Yep.
So yeah, you could put a feature request in if you want to see FireDAC added to it, or maybe NexusDB has extended FireDAC. I'm not sure, but yeah, it's supported.
Yeah, Glenn, I didn't know if you said is there FireDAC support for NexusDB. Didn't say that in the question, but
yep, you're right. It didn't. But yeah, it does work with Delphi. Berlin.
Yep. Hey, if they have an ODBC driver, you can do FireDAC ODBC to get to it. We had a question earlier about DB2 AS400, and Dimitri, who's the architect of FireDAC and AnyDAC before that, with his company DASoft. That's what he recommends to get to DB2 AS400. We do have a connection and driver interface for DB2 server running on places where DB2 runs other than AS400, but he recommends using the DB2 AS400 ODBC interface and do the FireDAC through ODBC to get to it. So there's lots of ways, and Jim has blog posts, and I've updated additional links, MongoDB links and so on, into the blog post, and we'll add additional components, additional links into the blog post resources as well. Let's see. Suppose you have three.
So
go ahead.
Yeah. I was going to say,
Keith,
I'm not sure what the network configuration is, but there's, I think it's called round robin DNS is what I've heard of being used before, where it's a configuration of the DNS server so that it picks a different machine each time the connection is made. As far as, so I'll explain that. They was asking if you have multiple middle tiers that are identical, how do you load balance that? So I'm not a network administrator, but I know there are round robin DNSs and different types of load balancers specifically that can do different things. They can monitor utilization of machines and use that to route it. They can just route it randomly, or not randomly, but first 1, 2, 3, 1, 2, 3, 1, 2, 3, different ways like that. So that it's a pretty standard network configuration.
Yeah, years ago we had an object broker when we were doing the Corba world, and you just listed in the object broker the different servers that you had for Corba, and it would go through them. You could build up some kind of your own. I haven't seen anybody who has sort of a turnkey REST load balancer, but it's not hard to create an endpoint, for example, for EMS or DataSnap that would do something in a middle tier that would keep track of how busy some of the different servers or services are.
Yes, Amazon offers a load balancer.
Yep. Okay. Yeah, you just create a list, a string list of IP addresses or machine names or whatever, and then randomly choose one if you didn't want to have a more directed load balancing. Yep. We don't have a component like that specifically. It'd be hard to do though. 10 lines of code, 10 minutes, he always says. Okay, let me scroll down. I have to go look for Amazon. There was a question about, does it offer a load balancer? Pavel Glavatsky, send Pavel a message. He's the expert on Amazon Web Services and all the different, they have so many REST APIs for all sorts of things. I'm sure they have an interface that you can call through REST that that gets you all of the instances that you create into a group, and there's probably a REST interface for how busy some of them are. So send Pavel.
It's called the Elastic Load Balancing.
Okay.
Part of Amazon Web Services.
Yep, there you go. And all those are REST interfaces, so it's really straightforward. And again, Pavel is doing more Amazon and Azure videos and blogging as he moves along. He chose for this one to do S3 storage, but he's working on samples for Azure storage as well and other parts of Amazon and Azure into the future. So if you go to the Embarcadero TechNet on the Embarcadero YouTube, we have a playlist called How To videos, and I think we're up to 30 or maybe more, 35. Our goal is to have hundreds of short 5 minutes, less than 5 minutes, 7 minutes. Definitely, well, maybe I went over on one, the installation one, maybe 10 minutes and 30 seconds, but little short 5-minute how-to videos to do something specific. So Pavel's put a few up already. I've put a bunch. Jim has put a bunch up. So the goal is to have hundreds of these across different categories: getting started, mobile development, enterprise development, IoT, app tethering, parallel programming, and so on. And so they're easy to find and tagged appropriately as well. So, and then they'll appear eventually under the different product pages on the Embarcadero.com website. So check out the how-to videos playlist on the Embarcadero YouTube channel.